In this session, we'll be talking about managing customer identity at scale in your B2C applications. My name is Mahmoud Matouk. I'm a solutions architect with AWS, and I'm also joined by Richard and Julian. They will be walking us through some of the lessons learned from scaling the NHS login system. But first, before we get there, I would like to just say, why is this a topic that we would like to discuss with you today, and what is the story about scaling identity? So to begin, identity actions in a B2C application are usually a low-frequency actions compared to the rest of your system. So usually, user signs up once in the life cycle of their interaction with your app. User can sign in once and have a session valid for several hours. And during this session, they can make thousands of calls to your backend without touching the IDB. So usually, with just tens or maybe a couple hundred transactions per second on the IDB side, you can have millions of daily active users working with your application. But in many situations, in many cases, there is unpredictable volumes. We have seen this in many situations like government portals running election-related applications or census or admissions in case of crisis, or health applications running every use case you can imagine about COVID-19, from testing, tracing, vaccination, and everything in between. And in many of these cases, you cannot predict volume, you cannot control the volume, and it's usually, you have to be fair to all of the users coming into your system, and you have to be able to scale and operate these systems correctly. We also have many customers that have seasonal bursts like Black Friday, Cyber Monday, tax season. And operating and managing all of these solutions efficiently in production requires a lot of planning, a lot of capacity management, and a great deal of optimization and monitoring and seeing what's going on in your system. So in this session, we'd love to share with you some of the lessons learned from the NHS system. I think every strategy and every lesson I would like to share with you is exemplified in this system. So I'm going to hand it over to Richard to walk us through what the challenges and how they got over this during the pandemic. Thank you, sir.
Thank you, Mahmoud. Let me get the clicker, make sure it's working. So my name's Richard McStay. I am Head of Delivery and Operations for NHS Login, which is part of NHS Digital. I am going to spend just 2 minutes before I hand over to Julian, who's going to take you through the good stuff, just to give you some context about what NHS Login actually is. So, a digital authentication and verification service for health and care applications in England and Wales. So, there are several of health applications out there in order for citizens to gain access to their information or to services that they provide. They come through NHS Login as part of their verification and authentication. It was developed in 2018 by, as I mentioned, NHS Digital. It now has 60 connected partners, and we're working with a pipeline of a further 100 to provide healthcare services and access to data within England and Wales. It's got 40 million plus registered accounts, and we get about 750,000 users accessing those services on a daily basis. Our model for trying to create this service within England and Wales was to make sure that we could create something that allowed for appropriate access to healthcare data and ask for the relevant level of verification to give people access to that information. So, as part of a standard that is created in England called DCB 3051, there are different levels very similar to NIST. And so we provide a service that allows applications to provide a requirement for low-level access, which we call P0, which allows for basic registration, and for services that don't require the identity of the individual. A medium level, which does a match against a user's NHS number, but again doesn't ask for any proof of identity to prove that they are who they say they are. So it's an assumed identity, asserted identity. And then for those services that want to provide much greater services, such as detailed record access, we also ask people for an ID document match. We do a likeness and a liveness check. And if they've got existing credentials that where they've proven themselves at a high level in a different service, we take those details and allow people to be identified at a high level. Users can uplift as required through the different accesses to services that they require. So they could begin as something like P5, for example, If they then want to access a service that requires them to be P9, a proofing level of P9, then they're allowed to uplift, they're able to uplift and provide additional information. These levels are passed back to that service, so our partners that we have request that a user is at a particular proofing level, and we pass those details back to say, yes, they meet this particular requirement. That's backed up by account management for the users to be able to control things like changing their passwords, updating details about themselves. It's relatively straightforward. Obviously, we've been here since Monday, and since the conference started on Tuesday. We've learned a huge amount, but our basic journeys, which we'll now go away and challenge, allow people to do a basic registration. So a partner would they continue with this NHS login button at the beginning of the journey, very similar to sign in with Google, sign in with Facebook. They will create a registration by entering username and password with an email address, which they confirm. We'll use two-factor authentication, sending an OTP out. We'll go passwordless. We'll use passkey. We'll remember everything that we've learned while we've been here and maybe change that. And that allows people to create a basic account. For the verification, we use an identity document. We ask people to either take a video selfie or have their face scanned. I think Alan on Monday talked about a service that he'd seen that has face scanning, which is different colors, and that's a service that we use to do a biometric check. We can automate that process, so an algorithm to work out whether that is okay, but if it's just a no or a maybe, based on a conversation I've heard in the last couple of days, we can pass that to a team of people that are trained up to do manual ID checking. And so that's the basis of the service. That's just to give you some context about what Julian's going to take us into. As I mentioned, we started in 2018. We had one or two partners internally, and we grew our particular service, developed and learned, made mistakes, and tried to build that up. By the time we got to 2019, we were very happy with the numbers. By the time the COVID-19 kicked in 2020, we'd got to 20 million people, accounts logging in for that particular year. I thought that was me done. That was a success. We didn't need to think about scaling. We didn't need to think about anything else. Now, I'm in a room full of very, very bright people. You all know what happened in 21, 22. That's the context of NHS login. Julian is going to take us on and explain what we did to cope with the numbers that we then saw in 21 and 22. Just keep an eye on that 20 million. And I'll hand over to Julian. And thank you. Clicker.
Thank you. Thank you, Richard. So I'm Julian Walls. I'm a principal consultant at InfinityWorks. I'm a tech lead on NHS Login. I've been working on that for 4 years. And like Richard said, we thought we were doing quite well. And begin the pandemic, 20 million users logging in a year. Great, that's fantastic. We were doing really well. Nothing to worry about. And then, as you say, 20 million. Then 2021 happened. 800 million logins for the entire year, which is a little bit of a difference. And really, in 2021, what was driving the traffic to us was two websites and apps. One was the recording of lateral flow test results, or antigen tests, and the other was the NHS COVID Pass, which members of the public in England used for international travel, to access bars, restaurants, large-scale events, and even nightclubs in the UK. And these two services between them had a massive impact on our traffic. So registrations per day went from 20,000 to 350,000. Registered users from 3.5 million to 38 million. Authentications per day, a small 125,000 in 2020, 12 million 12 months later. And the one that really, really mattered to me as a tech lead was the authentications per second. So from 20 per second to over 900 at 12 months later. But these statistics only tell half the story. Our traffic was massively unpredictable. Government policy announcements, news bulletins, newspaper articles, even features on daytime TV would suddenly drive huge amounts of traffic to our system without warning. And this resulted in irregular traffic patterns like this. And this is just one example. In this particular case, we scaled from 100 logins per second to over 900 in just 6 minutes. The trigger in this case, Boris Johnson, the UK Prime Minister, was doing a press conference. He just happened to mention the COVID pass. You can probably guess when he did it. And what I want to tell you today is, what do we learn from this? How do we deal with this unpredictable scaling challenge? And what lessons do I want to share with you today that we've learned over the last 12 months? The first is to consider using serverless services. So NHS Login's been built from the start using a serverless first approach to design. If there's a serverless way of doing it, we use it. Services like CloudFront, API Gateway, Lambda, DynamoDB, Cognito, SNS, and SQS, they all make up our core stack, and there's many, many more services that we use as well. And I really, really can't stress how important this has been to our success during the global pandemic. Because using serverless services has enabled our system to rapidly scale in response to the very unpredictable traffic and demand we experienced throughout the global pandemic. And to demonstrate this, I want to share this graph. This is a graph from the 24th of May last year. And on this particular day, one of the national broadcasters in the UK decided to do a feature live on TV on how to get your COVID pass. So we started off with API Gateway traffic at 1,200 requests per second, and it rapidly, in 5 minutes, went up to nearly 15,000, which is quite a bit a rise in a short period of time. What did we have to do to enable this to happen? Well, not a huge amount, really. No auto-scaling rules to define, and no pre-event provisioning. And in fact, pre-event provisioning would have been completely, utterly pointless because, like most things throughout the pandemic, we did not know this was going to happen. So why use serverless? Well, serverless services automatically scale, and they scale fast. No need for scaling rules, not necessarily any need for pre-event provisioning. But also, it was really cost-effective because with serverless services, you only pay for what you use. And that means you can have lots of spare capacity sitting there doing absolutely nothing whilst costing you nothing as well. And for us, this was really important because most of the time we were running at 10, 20% of our system capacity. It was all these unpredictable events where we'd have press conferences or news bulletins where it would scale to 90%. We didn't get charged for all that spare capacity sitting there unless we were using it. The second lesson is to know your quotas. So right at the beginning back of 2021, I got asked a question. It was this. Can NHS Login support every adult in England logging in up to 4 times a day? And that works out roughly about 190 million logins a day. And you won't be surprised to know, I didn't know the answer when somebody asked me this. But you may be a little bit more surprised to know that I didn't know how many users our system could support logging in. I didn't know where our bottlenecks were. I didn't know what our quotas were and what would happen if we exceeded them. So at the beginning of 2021, we started asking a series of questions, not just of AWS services we were using, but all the other 10 other providers we were using as well. What were our current quotas? What's our max capacity? One that sometimes catches people out, how quickly can you get to that max capacity? What happens when we exceed the quota? Are we rate limited? Can we increase it? How are we currently doing? And with AWS services, this was mostly, in most cases, we got some good answers back. But for some other non-AWS providers, we had some concerning findings. Things like we had hard limits, immovable quotas we couldn't get round. One of our services was really slow to scale out. It took 15 to 20 minutes. And if you look at the previous graph, that's 15 minutes too slow. We had one service where the amount of capacity that we had depended on how much their other customers were using them, which wasn't very nice. And in some cases, some of the services didn't rate limiters. And you might think, hey, great, loads of spare capacity. But what would happen in reality is that we send loads of traffic to it and we just crash and burn. But the good story here is, because we did this analysis, we knew where our bottlenecks were and where the vulnerable parts of our system were. And therefore, we could do something about it. So, know your quotas. Know how the services you use, scale, and behave. Read the docs. Work with suppliers, verify with load testing. And then monitor your quota usage. So in our case, we've got various alarms at different percentages. So if we hit 50% capacity for a certain service, it might trigger us to do a capacity review and see, do we need to do some further work down the line to increase capacity? Or if it's like 90, 95%, or even 100%, we might invoke some controls to divert traffic somewhere else. And when you've got all this information, what you can then do is resolve bottlenecks and protect the vulnerable parts of your system. And yes, you might try and increase your quotas. That's what we always try to do first. But you'll probably end up doing some traffic controls, things like rate limits, queues, or possibly diverting users down alternative routes. So the third lesson is to optimize your capacity. And what I mean by that is to make better use of what you've got. So if your current system capacity can support 500 logins per second, can you eke more out of it and get up to 600? You may be thinking, why would I optimize first? Surely I just want to increase capacity. And you'd be right, and that was really the first thing that we did, because increasing service quotas was always our get-out-of-jail-free card. Effectively, you ask somebody else to take your scaling problem away. It's great. Go to AWS, please get more capacity. Thank you. Job done. But sometimes it's not possible because you might hit harder removable quotas. You may have to do further architectural work to enable you to use those quotas. And sometimes it's not cost effective, particularly if you're not using serverless services, because it wasn't really, as I said, most of the time we were in 10, 20%. If I've got to pay somebody for all that capacity and I only use it for a fraction amount of the time, that's not really cost effective. So when quotas can't be increased, you've got a number of different alternatives. You can try and find an alternative resource with a completely different capacity pool, or you can optimize your current usage. And when we did both of them, we found the latter was more beneficial to us. I want to give you some examples. So we looked at optimizing our user journeys, and I think as Richard said, we've actually got multiple routes for a user to prove their identity to a high level. And some of those routes have lots of capacity. And some of those routes have really tight capacity. They tend to be the ones that involve uploading your passport, your driving license, doing the liveness check online. And we started asking the question is, how do we keep more users on these high-capacity routes? And by looking at the data, looking at dropout rates, user behavior, and things like that, we managed to find some remedial work that would keep 20% more of our users on these high-capacity routes, which was great for our scaling challenge, but it was also really good for the user experience because these happened to be the least friction and easiest to use. It was great win-win all around. But we also looked at optimizing our business rules because at this point, the system had been going on for 4 years. You made some design decisions early on, our use case had changed. So in one case, we had a task that ran when a user logged in. And this particular task, every time a user logged in, used a limited resource, one that was quite tight in capacity. And when we first started, we had users logging in once, twice a day, if that. And we were now in a situation where people were logging in multiple times a day. In one case, up to 94 times. I have no idea what that user was doing. But what we did start asking the question is, do we need to do this task every time? It turns out the answer was no. If they'd logged in recently, we may skip it sometimes. And also, did we need to run it immediately? Because if we didn't, we could queue it. And if you had a spike event, I showed you that graph earlier, you could absorb all that traffic and then process it at a sustainable rate. It turns out we could do that. We could queue it. So by doing some changes, we managed to actually reduce the use of this limited resource by up to 54% and therefore allow the system to scale further. But there's more. Optimizing system design. This was a big one. So we found 25% of our API gateway traffic was serving relatively static data. We weren't caching. 60% of our API gateway traffic was collecting user logs from the browser. Did we need them all? No, we didn't. We had no login strategy. Duplicate calls were in the same request, synchronous calls that could be asynchronous, and I literally could spend the next 15 minutes telling you all the sins that I found in the system. But here's the point. There will be inefficiencies in your system that you can fix to get more capacity so you can scale further with what you've got. You can get away with when you've got low traffic and high capacity, but when you're in a high traffic situation with tight capacity, you can't get away with it anymore. So we optimized user journeys, which was better for our users anyway. We revisited the business rules. We made some priority decisions. But as I said earlier, optimizing system design was the really good win for us because it was really easy to fix by following best practices, things like caching, queuing, timeout management, login strategies, really simple things that we all know as developers, but when we're building an MVP and we've got deadlines, perhaps we are not always as good at following. The last point I want to make here is that really is important, that there is always more that you can do to optimize. I want to give you an example. So in December last year, 4 days before a major government announcement, and in fact, we actually were told there was going to be a government announcement, so we knew it was actually coming, which was quite rare. We hit a hard limit on one of the services that we were using. And we didn't have time to re-architect. We didn't have any time to make major changes. But when we realized this, we looked at the data, we make some priority calls, and we reduced the use of this particular service by 40% without adversely affecting how the system operated. So it just really goes to show how much, when you put under pressure, how much you can find optimizations in your system. But whatever you do, you have to plan for hitting limits because, you know, traffic was unpredictable, particularly during COVID. And there's two parts to this that we sort of did. The first is we did some good old-fashioned capacity planning. We defined core journeys, what levels of traffic they could safely support. And then we rate limited these core journeys to avoid exceeding safe levels of traffic. And the key principle here was it's better to turn users away than let too many people on the system and lose control. So it's better to serve 500 logins per second rather than 550 and basically find that your system's basically going to crash. And the second thing is to plan for the user experience. So our key principle was to tell users right at the beginning, that we're too busy. But we didn't really want to do that. What we really wanted to do was divert them to an alternative route with spare capacity, which we sometimes did underneath the covers. But sometimes we might say, go find that medical record with the NHS number, and therefore you can access this route. We might queue the user for a short period of time if it was a short-lived capacity constraint, but ultimately we had to prepare to tell the user to come back later. Although nobody likes to do this, it's better than losing control of the system. I'm going to hand back to Mahmood, who's going to talk about queuing and waiting room solutions.
Thanks, Julian. Can I get the clicker? Thank you. I think these are very, very practical lessons you can take home if you are running systems at this scale and you want to achieve these millions of numbers. It is possible, but it takes a great deal of optimization. So one final thought before I let you go, I wanted to share a thought about if you have expected surge that happens into your system and you want to use a waiting room, how this would work. What is the high-level design or high-level idea of how would this work? You can use a CDN in front of your critical resources, like maybe your sign up and sign in pages, maybe the page that you use for scheduling or anything that has capacity that you would like to control. And in case of normal traffic, you have to set like the threshold of your acceptable capacity. And if volume is usually less than that, then forward everything to the origin. When a surge happens, then you start forwarding people to a waiting room component, simply queuing users. And every user gets into the queue, takes a queue number, and then you keep bullying from the front end with the monitoring in your system to decide when you can admit these users into your system. Once the user turns come, they are issued a token, and then you can take this token and route them through the CDN again to go to your origin and verify this token and allow them to access this. So this is a very, very high-level 10,000-foot view of how this can work. If you want to take this into implementation, because we have seen these use cases more frequently, AWS Solutions team did a reference implementation of a serverless waiting room component. It provides you with all of the machinery that you need to implement this high-level architecture. It exposes to you APIs you can integrate with from your app, so you can start adding users to the waiting room, clearing users from the waiting room, bullying the queue for current position. So all of these actions, you'll have APIs that you can integrate with. This is a pretty much very active solution. It has a GitHub repository. You can interact with the team managing it. And I think for your big spike or big surge, I'd say have a plan to integrate a waiting room into your solution. So I hope this helps you to plan for your next big event. And thank you again for joining us today. And please provide us with any feedback you have. If you have any questions for us, I think swing by the booth or catch us outside, because I think this is all the time we have today. Thank you.